Hi everyone. Okay, students. So in today's video, I want to show you how to find the local truncation error. So this local truncation error that we want to look at is for the 6 points scheme, explicit scheme, which is to solve the heat equation. Okay, so we want to solve this heat equation. Ut equals to Uxx using 6-point explicit scheme. And this 6-point is given as n plus 1 equals to half 2 minus 5r plus 6r squared n plus 2 over 3r 2 minus 3r plus 1n plus minus 1n, and then minus 1 over 12 r1 minus 6r plus 2n minus minus 2n. Sorry, it's not minus, it's plus. Okay, so this is our 6-point explicit formula to solve the heat equation. Now you can see that what we want to show you in this video is the local truncation error. And the LTE, local truncation error, is given by Tmn plus 1 equals to small u mn plus 1 minus big U mn plus 1. So in other words, to find the LTE, we have exact, this is our exact solution, minus with the approximation. So our approximation is the 6-point scheme. So this is our approximation here. Okay, so what we want to do now, we want to derive the LTE. Okay, so we're going to look at each term here. The first thing is you want to look at the exact solution. So let's look at the exact solution, which is our small n plus 1. Now I'm going to write it at u xm tn plus k. Okay, so just to recall our grid point here, we had a grid point at xt, where x is mh, x here is at mh, and t as nk. Okay, now let me just erase my whiteboard. Okay, so what we gotta do now is find the Taylor series expansion at k for t. So I have u plus kut plus k2 over 2 factorial utt plus k3 over 3 factorial. Okay, I'm not going to write that. Mn. Now, this is the exact expansion for the exact solution. Now, the next part, you look at the approximation here. For the approximation, what we got to do, you need to find the Taylor series expansion for plus 1, minus 1, plus 2, minus 2. So let's do that. So looks like my whiteboard is not clear. I'll just erase my whiteboard. Okay, so now what we're going to see here, let's find the Taylor series expansion for u m plus 1n, u m minus 1n, u m plus 2n, and u m minus 2n. So once I've obtained all that Taylor series expansion, then you can substitute to the standard equation here. Okay, so let's find for u m plus 1n. I can write it as u xm plus h for 1 here, tn expanding in terms of h respect to x. You have u plus hux plus h2 over 2 factorial uxx plus h3 over 3 factorial, not 6 but 3 factorial, which is 6. I'm going to write it at 3 factorial uxxx plus h4 over 4 factorial uxxxx, and so on. Okay, now similarly we can do that for u m minus 1n, where your h now, some part will have negative. So what we have here, we have u, h is negative h, ux plus negative h squared over 2 factorial uxx plus negative h power 3 over 3 factorial uxxx plus negative h to the power 4 over 4 factorial. Okay, and so on. Okay, I can simplify that. Simplify this term here, you get u minus hux plus h squared over 2uxx minus h3 over 3 factorial uxxx plus h4 over 4 factorial uxxx, and so on. Okay, this is for um plus 1n and um minus 1. Now adding these two terms, where add um plus 1n plus um minus 1n. That gives you u plus u, 2u. Now this term cancels out, and the fourth term cancels out. So h squared over 2 plus h squared over 2, which gives me 2h squared over 2. So h squared uxx, h4 over 24. 4 factorial is 24. h4 over 24 plus h4 2, h4 over 24. That will give me h4 over 12. Okay. N. Okay, that's good because we have considered the Taylor series expansion for this term, this term. Now we got m plus 2 and m minus 2. So let's expand that. So I forgot to clear my whiteboard. I cannot do it now until I finish recording this. So please, I might have to keep erasing as we go through. Wow, look at that. Okay, let me just clear the whiteboard before anything else. What's happening here? Okay. Okay, now we have enough room to write. Let's remove this one too. Okay, looks like I just wasted few minutes of my recording. Okay, clear. I hope so. Okay, now back to what we have. So find the Taylor space expansion for u m plus 2n, which is u xm plus 2h tn. Expanding this, we have u plus 2h ux plus 2h squared over 2 factorial uxx plus 2h cubed over 3 factorial uxxxx. Now, too many x, just third derivative, plus 2h power 4 over 4 factorial uxxx up to 4th derivative, and so on, mn. Now, simplifying this, we have u plus 2hux plus 4h squared over 2, which is 2h squared uxx. Okay, correct, right? 4, and then plus 8h cubed over 6. 8h cubed over 6 uxxx. 2 to the power 4 is 16. h4 over 24 xxx, and so on. Okay, now we can see that when you have another one with the m minus 2 sign, so it will be similar with the one we have obtained, where but the third term and the second term and the third term will be negative. So I can write this as 2 minus 2hux plus 2h squared uxx minus 8 over 6h cubed uxxx plus 16 over 24 h to the power of 4 u xxx, fourth derivative, and so on. Now adding these two terms, that will gives me u plus u is 2u. This two term cancels out. This term cancels out. That will leaves you with 4 h squared uxx 16 32 over 24 h to the power of 4 uxxxx. Okay, so this is what we got, the Taylor series expansion. Now, what is the approximation here? So you want to find the approximation for this 6 point here. Now you got to substitute whatever Taylor series expansion you obtain for um plus 1, m minus 1, and um plus 2 plus um minus 2 in this equation. So what we have, let's write it down. The approximation umn plus 1 is given by umn plus 1 equals to, let's write the one does not change, which is 2 minus 5r plus 6r squared umn. Okay, and then we have plus 2 over 3 r2 minus 3r. This term here, m plus n. Okay, this term, which is 2u plus h squared uxx, 2u plus h squared uxx plus h4 over 12, the fourth and so on. So, okay, so then mn, and then continuing the next equation here is my m plus 2 and m minus 2. This one, negative 1 over 12r, 1 minus 6r, m plus 2n plus m minus 2n. So let's do that. We continue here. Minus 1 over 12r, 1 minus 6r. What is m plus 2 and m minus 2n? This one. Okay, which is 2u plus 4h squared, 2u plus 4h squared uxx plus 32 over 24h to the power of 4 uxxxx and so on. Okay, so this is what we got, the approximation. Now let's find the LTE, where LTE is TMN plus 1, which is exact minus approximation. Okay, the exact solution is the one we expand respect to t earlier on, which is, what is it? Let me find this one. This is my exact. Okay, this equation here. Let me just label it equation 1. And then we have equation 2 here, which is the approximation. Okay, so let's minus. So I have u plus kut plus k squared over 2 factorial is 2 utt, and whatever the next term is, mn minus with this whole thing. Okay, so which is half 2 minus 5r plus 6r squared u. So let's write mn at the end, plus 2 over 3r, 2 minus 3r, 2u plus h squared uxx plus h4 over 12 uxxx plus whatever, continuing here, minus 1 over 12r, 1 minus 6r, 2u plus 4h squared uxx plus 32 over 24 h to the power of 4 uxxxx and whatever the term involved, mn. Okay, so this is the equation we got. Now we got to simplify. Okay, simplify means collect the common term involving u and uxx and the fourth derivative. Okay, let's expand this. So collecting the term involving u is this one, this one, this one, and this one, right? So we have u, don't forget the negative sign, half 2 minus 5r plus 6r squared u. Okay, we have one term here. And then we have this term here with u, but don't forget the negative sign, 2 over 3r, 2 minus 3r, 2u, and then this term here. But negative will be positive, 1 over 12r, 1 minus 6r, 2u. Okay, this is mn. Okay, now I'm going to continue here. Plus, I have kut plus k2 over 2 utt plus whatever the next term. And then we have to look at this. Okay, this is done. Whatever done, I'm just going to cross it out. I've written this thing. And I've considered this term, I've considered this term, I've considered this term. The next term is no longer this term, is h squared uxx here. Okay, so don't forget positive, negative. So I have negative 2 over 3r, 2 minus 3r, h squared. Let's collect another uxx term, which is here. But negative, negative will be positive. How do I do this? Into the exact sign? I don't know. Okay, so I have uxx and then positive 1 over 12r, 1 minus 6r, 4h squared uxx. Okay, this term is considered as well. H squared and 4h squared. Okay, remember this is multiplied with this term. This is multiplied with this term. Okay. This whole term here with mn. Maybe just don't do that yet because I have to consider my ut as well. So just leave it like that. Okay. And then what happened? I have to consider the h to the power of 4 term now. So positive, negative. So I have negative 2 over 3r, 2 minus 3r. So this term now. Okay. I have h4 over 12 uxxxx. Okay, that's one term. And then 32 over 24 multiplied with this, but negative. Negative will be positive. 1 over 12r, 1 minus 6r, 32 over 24. H to the power of 4 uxxxx. Okay, whatever the next term, we have mn for this bracket here. So we have 3 terms here. You gotta be careful. This is a lot thing. So first is this one, and then with this term and this term. So let's simplify. Where t mn plus 1 equals to, let's see this term. We're going to expand this. Factoring u, I have, so you can factor out u here. So I have 1 minus 1 plus 5 over 2r minus 3r squared minus 4 over 3r plus 2r squared, and I'm going to multiply by 2. So that will be, okay, let's put it like that. How do I do this? 2, that will make this one negative. Right, I'm factoring negative here. Negative, negative will be positive, okay, and then plus 1 over 12r minus half r squared. This whole thing I still have to multiply by 2, and don't forget umn, taking out the u term at the end. Okay, now we have plus, don't forget plus, so we have plus kut plus k2 over 2 utt, whatever term mn. Okay, Now this term here, let's expand this. Okay, so I have negative 2 over 3 will be 4. Okay, 2 times 2 is 4 over 3r plus 2r squared. Negative, negative, positive. 3 and 3 cancels out. This thing, don't forget h squared. H squared, and in a bracket like this. So uxx, and then expand this term here. I have, obviously we have mn. Okay, and then we have this one. 1 over 12r plus 1 over 2r squared 4h squared uxx. Or maybe I'll just take out the mn term for now. Oh gosh, it's so difficult to write this, but please do not make a mistake. So I'm going to take out this whatever mn. I'll put it towards the end, okay? And then expanding this term here, negative 4 over 3r plus 2r squared h to the power 4 over 12 uxxxx plus 1 over 12r minus let me just check, where's it minus? This should be 2 here, this should be negative 4, so this should be negative here. Negative, what do I have here? This times this, so I have 1 over 2r squared 32 over 24 h to the power of 4 uxxxx. Okay, now this whole term, how do I do this? Maybe this whole term here, and don't forget positive sign here. Okay, I gotta tidy up some of my term here. So let's be careful. Let's see whatever cancels out. So this and this cancels out. Now we have this. Let's see. So we have 5 over 2r minus 3r squared. 2 times 4 is minus 8 over 3r plus 2 times 2 is 4r squared plus 2 times 12. So we have 1 over 6r minus r squared. This is umn plus, I have this term k ut plus k2 over 2 factorial utt whatever mn. And then, oh, this is the one that is going to be headache now. Let's collect all the term involving uxx. So we have plus negative 4 over 3r h squared plus 2r squared h squared. And then we have 4 times 12 is 1 over 3 r h squared. And then negative 2r squared h squared. This is uxx. Okay, done. Now let's collect this term now. So I have plus negative 4 over 3 r h4 over 12 plus 2 with 12, so 1 over 6 r squared h4, and then this with this 32 over, can I simplify this? How do I simplify? Oh, let's just write it down. Plus 32 over. Okay, now we have this term. What I'm doing is I'm doing this term, right? So don't forget 1 over 12 of the return. I have RH4 and then negative this term. This 2 would be negative 2 and 32 will be 16 over 24 r squared h to the power of 4. This is u x x x x. Now don't forget this whole term here. You need to have mn. Okay, this looked much better than earlier on. So all you gotta do is simplify and see what term left. So let's see. We can see that for r squared here, 3r plus 4r will let me with 1r minus with this r. So this term cancels out. Now to this term, let's the denominator multiplied by 2 and 3. So 15 minus 16 is negative r plus r. So this term cancels out too. So the u term cancels out. That leaves you with the term involving t, k ut plus k2 over 2 utt mn. Now let's look at the term for the x derivative. This term cancels out. Negative 4 over 3r plus 1 over 3. So I have negative. So I have negative rh squared uxx. Okay. For this term here, let's see what do I have. So let's do for this one. We can simplify some of the term here, which is 4 divided by 4 is 1, 12 divided by 4 is 3. And then what about this one? 12 divided by 6 is 2, 32 divided by 6. Now we can divide by 6 divided by 4 is 3. 32 divided by 4 is 8. 8 divided by 8 is 1. 24 divided by 8 is 3. So negative 1 over 9 RH4 plus 1 over 9 RH4. So this term cancels out. That's good. Now this term, let's simplify. So divide by 8, I have 2. Divide by 8, I have 3. So 1/6 minus 2/3, or I can equate the denominator, which is 1/6 minus 4/6. So 3/6 minus 1/6 minus 4/6. So I have minus 3 over 6 R2H4. Okay. Now, there you go. We have come to simplification. This is a half, right? Okay, let's look at this term here. Now, since we know that r equals to k over h squared, this will give me k ut, let's take this to term, minus r equals to k over h squared. So I have kuxx, and then this term here, since this is half, let's simplify. So I have plus k2 over 2 uttt minus, okay, what is r squared? K squared over h squared. So I have 1 over 2 k squared over h squared cancels out h4 and h2, leaving h2 uxxxx. Mn. Now, since we are solving the heat equation, this is our heat equation. If I take out this term K, I have UT minus UXX. Okay, and then take out the common term involving K squared over 2. I have UTTT minus, sorry, I don't have H squared anymore. Okay. You won't be able to have H squared because of R squared. So this should just live with K squared. Because if this is R, what is R squared? I have K squared over H4. So H4 and H4 cancels out here. So that will give me this term. Mn. Okay, so this is the heat equation. Ut equals to Uxx, right? So this term cancels out. Therefore, that will leave me with the principal part for the LTE, which is this. Okay, so this is how you find the local truncation error. So this is a principal part of the LTE where we can see that from here. What can you say? That's the main thing. What can we say? We can say that the order of accuracy is given by K squared term here. Okay, so that's the end for the LTE of the 6-point scheme. Thank you for watching. Bye for now.